Alright, so this is the test. My memory card kind of pooped out on me, and so it cut me off right in the middle of filming, and I had no idea. So I'm just going to kind of go over a couple things with you on what we did here, what I did just to do the fractional distance. So let's go through number one. I'm going to try to film these as fast as I can and get them put on Google Classroom, since YouTube decided to funk out on me tonight. So there's two ways we can solve this. We can use the formula for fractional distance. Okay, so there's the question right here. Let me pull out a little bit with the focus. Okay, so what we have here is we're trying to find fractional distance. So I want to find the point that is 2/3 of the way from A to B. So A is going to be the starting point. It says from A to B. So A is your starting point. So A is going to be your x1, y1, which is how I labeled it up here. Okay, so that's point A. Point B is going to be your finish point for the whole segment. So you're going to finish this way when we go A to B. But if we go fraction of that, your finishing point is going to be here, which is what we ended up finding. So B is your x2, y2. So we're going to find the distance, the point that is 2/3 of the distance from A to B. We're not going to go all the way to the finish. We're just going to go 2/3 of the way. Okay? So here's what I did the first one. Here's using the fractional distance formula. Fractional distance formula is here for x and for y. And let me underline x in purple so you can see that a little bit better. So basically the fractional distance formula is a way to do everything in one shot. You know how we found the absolute value of the distance, and once we found the absolute value of the distance, the difference, we got the distance. We multiplied the distance times the fraction and then added or subtracted. Well, let's use the formula here. So xf is your fractional coordinate you're looking for, the x coordinate. So x1 is where you started, and we started at A, right? So we're going to start with 2. So it's going to be -2 plus k, which is 2/3, that's the distance we're traveling, 2/3, times 4 minus -2 was what was there, and I changed it to plus a positive. 4, which is x2, minus -2, which is x1. So all I did was plug in. Then from there, that gives me -2 plus 2/3 of 6. And from there, that gives me -2 plus 4, because 2/3 of 6 is 4. And -2, which is your starting point, plus 4, which is 2/3 of your distance, which is what you just calculated, is 2. So the x-coordinate is 2. And at that point, you could have eliminated the rest of the answers, but remember, I'm requiring you to show your work as well. So let's find the y-coordinate. y1 is your starting point, which is -8, plus k, which is 2/3, that's your distance, times the difference, y2 minus y1, so 7 minus -8, minus a negative changes to plus a positive. So I get -8 plus 2/3 of 15. 2/3 times 15 gives you 10. And then -8 plus 10 is 2. So your y-coordinate is 2, which is how we got 2, 2. Now that's using the formula. Now you can also, down here, use the standard way of doing it. Okay, this is without the formula. And this is the way we were doing it before. I showed you the long way first. So what we're doing here is we're taking the difference between the 2 points, which is 4 minus -2. It doesn't matter what order you do it in because you're taking the absolute value. I just want to know how far apart 4 and -2 are, and they end up being 6. Well, I don't want to go the full 6. That means I went 6 left and right. Okay, so if I'm doing, if I'm showing you on the graph, that means that to go the full distance, I went 1, 2, 3, 4, 5, 6. Okay, that full distance is 6. I don't want to go the full distance. I want to go 2/3 of that distance. So I'm going to take 2/3 of 6, which is only 4. So instead of going over 6, I'm only going to go over 4. And I started at -2, so if I go to -2 and I count 4, I end up at 2. That's 4. That's my fractional distance, okay? So now I'm going to do the same thing for the y value. The y value, I find the distance between the y-coordinates, 7 and -8. I do that by doing the difference. Sorry, I'm kind of rushing this. I want to get this up on Google. So 7 minus -8 is 7 plus 8, which is 15. Now, 15 means that to get from this point to this point, originally, we went up 15 units. But I don't want to go up 15 units. I only want to go 2/3 of the way. So I'm going to take 2/3 of 15, which is 10. So instead of adding 15, I'm only going to add 10. And remember, he started at -8. So if I start at -8 and I add 10, I'm going to end up at 2. So that is how we end up getting, this is your fractional distance, 4 and 10. That's how we end up getting our fractional distance coordinates. Okay, so let's look at the next one. Let's look at, this one should have been a pretty simple one. I think some of you overthought it. We're trying to find the midpoint of 2 points, okay? So, or the end point. So I've got one end point down here at 8, -10. And then I've got my midpoint listed right here at the origin at 0, 0. And a lot of you just counted. Remember, this is not always going to work. You're not always going to have a midpoint right in the center at 0, 0 and make it all nice and neat. And you're not always going to have integers. You're going to have decimals and fractions and all kinds of ugly things. So we need to know how to do it algebraically. So let's do the y values. The y values, here's where I started. I started at endpoint number 1. Sorry, my kids are yelling. I started at endpoint 1. If I look at endpoint 1, I started at 8. Sorry, we're doing the x values first. To get to the midpoint, I went from 8 to 0. So what did I do? Well, I went 8 units left. So I went 8 units negative direction. So I subtracted 8 to get from one endpoint to the middle. Well, since it's in the middle, I have to subtract 8 again to get to the other endpoint. So 0 minus 8 is -8. So that puts us at -8. Now if I do the y values, I started at -10 for one endpoint, right? And then how did I get to the midpoint? 0. Well, I added 10. So to get to the other endpoint, I've got to add 10 again, plus 10. So that gives me 10, which is how we got the answer D, which is at -8. Whoops, not -8, sorry. C, -8, 10. -8, 10. So the answer was C to that question. So that's how you do the endpoint, midpoint. Okay, the next one, again, I had filmed a lot of this before I realized that my memory card went out. So if we look at this one's asking what are the coordinates of the point halfway between Julia's house and Alice's house. Julia and Alice are these two. The city hall was there to throw you off. That's what we call a distractor. That's something that, a piece of information that's thrown in there that we don't need, but that you seem to be, that you want to use, okay? It seems like YouTube might be back up. No, never mind. I got excited there for a minute. So anyway, so what we're going to do is we're going to find the midpoint. Halfway means midpoint. And a lot of you trying to use the formula messes you up. Ignore the formula. Pretend like you don't have a formula. How do I find a halfway point here between two values? Well, if I have 2 and 8, how do I find the average? Well, I do 2 plus 8 divided by 2. That's what the midpoint is doing. It's taking the average of the x's and the average of the y's. So my 2 points were at 2, 4 for Julia's house and 8, 8 for Alice's house. Okay, so I did 8 plus 2, which are my 2x coordinates. Some of you messed up because you put 2 plus 4. That's an x and that's a y. You're finding the average of the x's and then the average of the y's. So 8 plus 2 is 10 divided by 2 is 5. 4 plus 8 is 12 divided by 2 is 6. So that is our midpoint halfway. You just find the average of the x's and the average of the y's. Okay. All right. So let's look at the bonus. Okay. I'm looking at the bonus. The bonus was somewhat clear, a little bit unclear, I thought. It's asking you what is the greatest distance? The distance that is halfway from, or 1/3 of the way from A to I, or halfway from H to I. Okay. Which distance is shorter? Now, again, shorter. Some of you did longer, and that's why you didn't get it correct. So I'm going to look for the first one. Let's look at HI. Hi. So I'm going to go from H to I. And I want to find the point that's in the middle and determine how far away that is. Then I'm going to take 1/3 of the distance from A to I. So we're going to take the full distance from A to I is here. Now, looking at the graph, if you didn't pay attention that you were going to be doing fractions of distances here, you would have messed up. So let's do this first. Okay. How long is HI? Well, that's always distance formula, right? Length is distance. We're not doing fractional distance for HI. We're going to do fractional distance for AI, but not HI. HI is plain and simple the midpoint, right in the middle. Now, you don't have to find the midpoint. You can. That's an extra calculation you don't need. Basically, how would I find out what the halfway distance is? I would find the distance of HI, and then I would cut it, in what? Half. So here's your distance formula. Okay, so here's your distance formula. So my coordinates for H and I. H is at 0, 0. I is at 18, 14. Okay, so let's find out how long this thing is. All right, what are my two x's? 0 and 18. So 18 minus 0. What are my two y's? 14 and 0. So 14 minus 0. So the distance, or the length of segment HI is 18 squared, the square root of 18 squared plus 14 squared. Okay? This 18 squared is 324, and 14 squared is 196. So the difference, or sorry, the distance, I'm trying to show you this. So what you're doing on the calculator here is you're going to, if you want to square it, you do 18 squared. And because I'm smart, I know it's 324. Well, I don't know if it's because I'm smart. That's probably up for debate. And then 14 squared is 196. So when I add those two together, 324 and 196, I get 520. Okay? So the length of my segment is the square root of 520. Now, some of you forgot to square root it. You put 520. The length is not 520. It's the square root of 520. So I'm going to do second square root of 520. And I get 22.8, right? But I don't, 22.8 is the distance all the way across. I don't want the whole distance. What do I want? Half the distance, right? So I'm going to do the 22.8, and I'm going to divide that by 2. So that equals 11.4. Okay, so what does that tell me? That tells me that the midpoint, which happens to be at 9.7 right here, this distance right here is 11.4 units. Okay, so now I'm going to compare 11.4 units to 1/3 of the way from A to I. Okay, so let's find out first of all how long AI is. All right, and again, this is not necessarily fractional distance. I kind of said that at the beginning, but we're really not going to use fractional distance here because for fractional distance, we actually want coordinates. You don't need coordinates here. We're just comparing lengths. I want to know what's the length of 1/3 of that. What's 1/3 of that right there? So let's look at A. A is located at 3, 5. Okay? And we're still going to I, right? So I'm going from 3, 5 to 18, 14. So let's find the length of AI altogether. Okay, the length of AI would be, okay, 18 and 3 are your two x's. 14 and 5 are your two y's. So the length of AI is going to be the square root of 15 squared plus 9 squared. Then I'm going to move on and square those, so the distance is equal to 225 plus 81, okay, which is going to end up being 306, the square root of 306. So if I wanted to add these on the calculator, again, just to verify, 225 plus 81 is 306. Now, I want to take the square root of 306. Whoops. Second square root 306. So I get 17.5 But I don't want 17.5. What am I comparing it to? 1/3 of that. So I'm going to divide this by 3, and I get 5.8. So 1/3 of the distance here, okay, 1/3 of the distance here, which is actually going to be at 8, 6. Hold on a second, I'm thinking. So you've got 15, you're going to add 10, so it'll be 1/3, so it'll be at 8 and 8. So your distance here is 5.8. So which one is shorter? The shorter one is 1/3 of the distance from 8i. That's the shorter one. Now, it's kind of open to interpretation. I looked at how you did it. Some people found these 2 points, but they thought that it meant find the distance from the origin to here, the origin to here. So it was kind of misleading, but I looked at it and looked at what approach you took. But a lot of people, you didn't put which one was shorter, you put which one was longer. And some people just made some errors in their calculations with arithmetic. So make sure you're careful with your integer values, okay? So that's the bonus. Now let's go on and do this one here. What's the point that is 4/5 of the distance from -5 to 15? I'm going to do this 2 different ways. I'm going to do this with the fractional distance formula and without. We're going to do it without first. So on a number line, I want to go from -5 to 15, okay? But I only want to go 4/5 of the distance. So the way I figure this out is, first of all, I got to find out how far apart these guys are. So I'm going to do 15 minus -5. Remember, you take the absolute value of the difference, and you end up getting the absolute value of 20, which is 20. So 20 is the full distance that these guys are apart. But I don't want 20. I want 4/5 of 20. So I'm going to take that 20, and instead of doing 20, I'm going to multiply that 20 times 4/5. And when you multiply 20 times 4/5, you get 16. So I want to know what point is 16 units this way, 4/5 of the distance. And so to do that, I take my starting point, which is -5, and I'm going to add that 16 on there, and I get 11. Oops. So 11 is my point. A lot of you put 16 as your final answer. 16 is how far you're moving. You're not done yet. Remember, you started at -5. So 16 is how far you're going to travel from your starting point, okay? If I were to use the fractional distance formula, then you can do it this way. Some of you like doing that, okay? The fractional distance formula, and we just have an x coordinate or just one coordinate, would be your starting value, which is -5, plus 4/5 times your finishing value minus your starting value. And you see how that's going to come out the same way? I've got -5 plus 4/5 of 20. Isn't that what we did over here? -5 plus 4/5 of 20. So you're going to get the same thing, -5 plus 16, which is 11. So that's the 2 different ways you can do it. Okay, so let's look at number 6. Number 6 said a line segment AB is 4 units long and has 1 endpoint at A4, -3. And remember, I told you on the test there was a misprint, and to actually correct that to be at 4, -3, okay? So you should have moved your point down here. Which coordinates could represent the other endpoint B of AB? Okay, well, A is at 4, -3, okay? Now, it's AB is 4 units long. So look what you could have done. Let's graph all these. Let's graph A, -4, 3. Does that look like it's 4 units long? No, you could verify it with the distance formula, but there's no need. Okay, so that one's out. So it's not this one. Let's look at the next one, 0, 0. Does that look like it's 4 units long? Could be. So we're going to put a little question mark here. Kind of check it out. All right. 4, 1, right here.